Hey guys, welcome to a new video of what hopefully becomes like a new series on calculus. Today's lesson is going to be derivatives. So what is a derivative, where does it come from, why do we need derivatives, and so on. So to start off, let's say we have a graph, alright? Got our y-axis, x-axis, and we just have, a graph that looks like this. So say we have this point on the graph. It can be any random point, doesn't really matter, but let's say it's that point. Now, if we were to find the tangent, the line that is tangent to the graph at this point, how do we find that? So we know how to find a line, or the slope of a line, when we have two different points. So for example, if I have a point here and a point here, I can connect them up, and I can find the slope of this line. But how do I find the slope of this line? Now I know this line goes through this point. Oh, and what's special about this line, it's the tangent line to the graph. So that means it only touches this graph at this point that we chose. So we know how to find the slope of a line when we have 2 points, but how can we do it when we have 1 point? So let's see here. Let's say instead of this line, or let's say that we take another point on the graph. Let's say we take the point right here, and we connect them up. Now let's move our point a little closer to here. We connect them up. Now let's move it a little closer up to here. Connect them up. And you can see as we get closer and closer, as we bring our second point closer and closer, we get closer and closer to the actual line at this point. As we bring this point closer and closer, so first it started out here, then it's like here, then it's here, then it's here, and we're slowly getting closer to this actual line that we're trying to find. So let's say that at this point, the value, the x value is just x. And let's assume at this point, let's say this goes down, let's say this distance right here is dx. So then this point is going to be x plus dx. Alright, so now we have 2 points. We have x, or we have the value of the function at x, or we have x and then we have x plus dx. So what's going to be the value of the function, the y value, at these points? So let's say our function is f of x. So at x, the value is just going to be f of x. And at x plus dx, it's just going to be f of x plus dx. So then this point is x, f of x. And this point over here is going to be x, f of x, the value over here is going to be x plus delta x, or dx, dx, comma, f, x plus delta x. Right, we're just plugging in x plus dx in place of like the x here. Should make sense. So now we have to find the slope. So how do we find the slope? Now that we know 2 points, it's just y1 minus y2 over x1 minus x2. So let's take this one first. Our y value for this point is f of x plus dx. F of x plus, or delta x. They're not really interchangeable, but that's my bad. Yeah. F of x plus dx minus here, our y value here, which is just f of x, divided by our x value here, x plus dx, minus our x value here, x. So I'm just going to write it down here. The x's cancel, and we have f of x plus dx minus f of x divided by dx. And this is the slope of this tangent line when dx is really, really small. Because you remember, when our other x was all the way over here, this line is kind of off. But as we bring this point closer and closer, we get closer to the actual line we want. So this is when dx is really, really small. So we just write here, limit dx tends to 0, f x plus dx minus f of x divided by dx. And this is the slope of this line. This is the slope of any point on any graph at x. Alright? So let's work through an example now. Let's say our function is anything. I don't know. Give me one sec. Let me pause this. Okay, so let's say our function is x squared. Y equals x squared. So let's plot it out real quick. It's going to look something like this. And now let's say we want to find the slope of the line at this point. And let's say this point is 1. So we want to find the slope of the line at the point 1 on the graph y equals x squared. So let's use our little formula here. So limit x tends to 0 of f of x plus dx. So f of x is basically x squared. So we plug that in. And we know x is basically just 1. We know x is 1. So that's going to be 1 plus dx whole squared minus f of x. So that's just 1 squared divided by dx. So this equals limit x tends to 0, 1 plus 2 dx plus dx squared minus 1 divided by dx. So the 1's cancel here, as we can see, and we're left with limit x tends to 0, 2 dx plus dx squared divided by dx. We can cancel dx from all of these, and we're left with 2 plus dx. Now, we take the limit. Dx, sorry, this isn't x, this is dx. It's my bad. Dx is tending to 0. So we can just neglect this. This doesn't matter. And the slope is 2. So the slope of this line that goes through this graph, x squared, at the point 1, is equal to 2. And that's how derivatives work.